All right, let's take a look at sample problem 4. Now remember, after I've read the problem, if you haven't tried it yet, pause the video and give it a try, and then take a look at the solution. All right, so we have Pua here. Pua has saved $6,500 over the last couple of years. She decides to put this amount into a savings account that earns a 0.95% compounded continuously. How long will it take her to have $8,200? So first thing I want you to note here is that it says compounds continuously. And that is the one case in which our formula B equals P times 1 plus R over N to the power of NT is not appropriate. So if you remember from earlier in the unit, we learned that when we have continuous compounding, that this portion here goes to, as we go to infinity, goes to what we call E. So the formula we're going to be using here looks a little different. So we're going to be using our B equals P E to the power of RT. So we will always use this formula when we have continuous compounding, just because continuous goes to infinity. And remember, like I said before, this portion here of the equation, as we take the limit to infinity, will take us to that exponential E. All right, so let's go ahead and do just like we did before, and let's identify what pieces of information we know. All right, so we know that she's currently saved this $6,500, right? That's the amount she's putting into the account, so that's our principal. We know that she's hoping to have $8,200, so that's the balance she would like to achieve. We know that the rate at which she's earning this is a 0.95%. Now you need to be really careful because remember, we don't put in the percent, we put in the decimal. So this is a 0.0095. So that's our R. And then we don't know the time. So that's what we're trying to figure out, right? So we want to know time, how long. All right. So let's go ahead and let's begin. Let's plug in what we know. So we have 8,200 is equal to 6,500 E to the 0.0095 t. Now remember, when solving an equation, we want to reverse PEMDAS. So we ask ourselves, is there any addition or subtraction to remove? And there is not. Is there any multiplication or division to remove? There is. So remember, our objective is to get the t by itself. So we're going to divide both sides by the 6,500. On the right-hand side, they cancel. On the left, let's take a look. We have 8,200 divided by 6,500, and that's about a 1.2615. Okay, 1.2615. And we want to round it as little as we can. I mean, clearly that number was going to go on and on, but we want to extend it as a few decimal places to increase the accuracy of our final answer. Is equal to E to the power of 0.0095 t. Now, ultimately, we want to get this t out of the power. So we're going to take the log of both sides. Now, the simplest thing to do here is actually going to be to take what's called the natural logarithm, or ln, because we know that the natural logarithm is the mathematical opposite of our base e. So we're going to take that of both sides. All right. Now, when we do this, just like we did before, when we take the log of something, the power property follows. So we know that power is going to jump out front. So we have the natural log of 1.2615 is equal to our 0.0095 t. And then we have our ln e. And mathematically speaking, the natural log of e is 1. So this part over here is simply going to cancel. So remember, our objective is to get t by itself. The only thing with the t currently is that 0.0095. So we're going to divide both sides by that, 0.0095. They're going to cancel on the right. And then all we have left on the right is t. And then we're going to go ahead, and I think we're going to just use the Desmos calculator here. So we have the natural log of 1.2615, the natural log of 1.2615 all over 0.0095. 0.0095. And we can see that that's about 24 and a half years. So we're going to say then that the time is about 24.5 years. And then let's check. Okay, so she had 6,500 and it was compounded continuously at a rate of 0.95%. And we are saying that about 24 and a half years, she will get to that 8,200. And there we go. 8,200, $3 and about 43 cents. So I think we feel pretty good about that.